So I'm going to get started. Got a couple minutes left, but I think we can just get going. So I hope everybody had a restful spring break and are doing okay with all the changes learning online. Okay. And again, if you have any questions as we're going along, feel free to put them into the chat, and I will work on those. But I only had one request from this week's work so far, so I'm going to pull that one in and we'll talk about that. Okay, and then I'll see if anyone else has questions as we go. But here's our first question. Okay, so this is from the, let me pull it up, the exponential growth, the compound interest homework, I believe. Let's double check. The compound interest, no, not the homework, the online, check for understanding worksheet. Okay, so which is, if you want to see it, this worksheet. Okay, so I'm doing number 15 on here, and this is all about compound interest. So just to remind you, I'm going to write down the formula that was in the video, okay, which is this one. It was A, or it might be P in there. Let's actually pull it up. Maybe I'll just copy it over. Oh, I actually have the compound interest one up. We can actually just go look. Here's your formula. Okay, so this formula right here, P times 1 plus R over N to the nt, right? So it's a formula. P is principal, which is basically just means like the starting value. A lot of times compound interest refers to money. So principal is your starting balance. Okay. R is annual interest rate. So annual means yearly, right? So the R value will always be the annual interest rate. N is the number of times the interest is compounded per year, right? So you're going to start to see some keywords like monthly and daily and yearly and, quarterly, right? And that's going to tell us what our N value is. And then T is how many years have passed, right? So generally the exponential formulas, this exponent is not years. It doesn't have to be years. It could be days or minutes or months or something. But when we're talking about the compound interest formula, it is going to always be years. Okay, so I'm going to actually pull this into, our question. Okay, and I'm going to put it in the corner up here so we have it. Okay, so taking a look at this problem, it's saying that we have $1,000 and we would like that $1,000 to become $2,500, right? So what we know is that the P is 1,000. Okay, they're telling us it's 2.25%, so that's our R. Okay, they're saying it's being compounded monthly or quarterly, right? So that's going to tell us the N value. The N value is the number of times the interest is compounded, right? So when I say monthly in a year, that's going to happen 12 times, right? So that's kind of all the information that we need. The tricky part about this problem is they are not telling us the number of years, right? We don't know what T is. They're actually saying how many years. That's the question. But what they are giving us is that the output value, which is A of T, right, the left-hand side of this, is got to be over $2,500, right? So here's what we're going to set up. If I plug in all the information, and we'll do this first one, okay, letter A. Okay, so let's see if I can write nicely. It's been a little while, okay? So I know that if I were looking at my equation, that on the right-hand side of the equal sign, the $1,000 is P, so I'm going to write that down first. Okay? And then in the parentheses, it's always 1 plus. Okay. Our R value is the annual interest rate, which is 2.25%. We have to write that as a decimal, right? So 0.0225, okay, over, and then our N value, because it says monthly, right, and N represents the number of times it's compounded per year, monthly means that we're going to have a compounding 12 times, right, in a year. Okay, so that's 12, okay? And then my exponent is going to be N times T, right? Well, my N value is still 12, okay? And I don't know T, right? So I'm going to leave that alone. That's still just T, okay? But what I know is that the other side of this equation, the output, should be 2,500. So where A of T was, we're going to replace that with 2,500. Okay, so this is the equation. And so here's the thing about this equation. And I don't know if I mentioned it in the original video. We can't solve this equation right now, okay? You're going to learn shortly how to solve something like this, and then when we do that, we'll revisit it. But we don't know how to solve for exponents. That's not a any topic that we've covered so far. Okay, so the only way that you can answer a question like this is to pull out your calculator and do a little bit of guess and check. Okay, so I'm just going to pull up my calculator. Okay, and we're going to do a little guess and check. So the first thing I'm going to do is I'm going to simplify this inside part here. I can do all of this math, right? So I can actually just go to my calculator and type in 1 plus 0.0225 divided by 12, right? And so that would be this number right here. So I'm going to write that down, okay? Instead of the unsimplified version like this. This is 1.008, I believe it was. Yep, 001875. Okay. So this inside part becomes that number, okay? Still to the 12t, okay? And then I'm going to put the 1,000 on the outside, okay? So what our goal is going to be is we're going to take this expression and we're just going to start plugging in t values, right? We're going to see what makes it go to 2,500. So I'm going to make a guess, right? I have no idea what the answer to this is, right? But I'm going to say if I take 1.001875 and I raise it to, with my x to the y button, let's try putting a t is 5, right? So 5, let's fix that. If I plug in 5 here, that's going to make my exponent 12 times 5, and that is 60. So I'm going to raise this to the 60th, okay? Get that answer, and then do times the 1,000. Because remember, when you're doing this, notice what I didn't do, okay? I did not do 1,000 times this thing, and then raise it to the exponent, right? We have to wait on the 1,000 until we do this number to, I just did it to the 60th, right? I plugged in a t value of 5. 12 times 5 is 60, right? And I did 1.001875 to the 60th, and then I multiplied that by 1,000, and I got this number, which is only $1,100, right? I have to get it all the way up to $2,500, so I wasn't even close, right? So let's try again. Okay, so I'm going to clear, and we're going to try again. So I'm going to say 1.001875, okay? And now I'm going to raise that to, and let's pick a much bigger number. I'm going to plug in, let's say 50, right? So if I plugged in, let's just do 100, right? So I'll plug in 100. So 12 times 100 is 12. Actually, let's do 50. I think 100 is too big, okay? So I'll do 50. So if I do 50 times 12, okay, I'm going to get 600. So I'm going to raise this to the 600th power, okay? And then I'm going to go and times it by 1,000. Oh, I subtracted 1,000. If I times that by 1,000, I get, I think it was 3,000, right? 1.001875 to the 600th, okay? And that's 3, and then if I do times 1,000, okay? So that's $3,000, right? That's too much. I only need 2,500, but I'm a lot closer, right? So 50 years was closer, so let's lower it a little bit, and let's say 40 years, right? If I do 12 times 40, I get 480, right? 480, okay? So now I'm going to do 1.001875, and I'm going to raise that to the 480th power, right? Because that's 12 times 40, okay? That's pretty close, times 1,000, okay? That's 2,457, right? So 45, is that what it is, 45? No, 40, 40, right, was pretty close. So you can see I'm just kind of guessing and checking my way through this. I think we'll try 42, right? So if I do 12 times 42, that's 504. So if I do 1.001875 to the 504th power, that looks a little bit over, right? Because if I do times 1,000, I get 2,570, right? So maybe it's just 41 then. So 12 times 41 is 492, 1.001875, okay? Let's try that again. 1.001875 being raised to the 41 times 12, which would we say that was? 492, okay? And then, yep, so that's going to be it, right? So, and then times 1,000, okay? Okay. So if you notice, now I'm at $2,513. Okay, so that's what they were asking for. How long is it going to take to reach 2,500? Well, it looks like during year 40, we were below $2,500, and during year 41, we're above that, right? And so it looks like sometime during the 40th year, right? It might have been in the middle of the year or something. We reached $2,500. So that's the best we can say for a problem like this is that sometime during year 40, we don't know exactly when yet, but we can say sometime during year 40, our $1,000 became $2,500. Okay. I'm not going to do letter B because letter B is pretty much the same thing. The only difference, which I will point out, is that because this one says quarterly, instead of your n values, which show up twice, being 12, like it was for monthly, quarterly just means it's going to happen once every 3 months, which is 4 times a year. Right, so these numbers would be fours, but everything else will be the same. You'll just put in 0.02 over 4, right? Simplify that number, and then you just keep guessing and checking to figure out what that one is. And the answer to that one's on the key. So if you want to look at, let's find out what the answer was. Okay. And again, if anyone else has any other questions that you want to go over, either about compound interest or about the introduction to logarithms, which is a very new topic. So you can post those into chat. Okay. And I'm going to mute myself. If there's any other questions, post those, and I'll be monitoring this for a little while just to see if anything pops up.